Hello friends, welcome back to my classroom. In this class, I'll try to explain what a Markov chain is and how to represent it using a transition matrix. A Markov chain is a stochastic process where the future state depends only on the present state and not on the past history. What this means is you will need only the current state to predict the next state. Okay, and the past doesn't matter. For example, to predict whether it is going to rain tomorrow, we only need to know whether it rained today or not. Okay, it doesn't matter whether it rained yesterday, it doesn't matter whether it rained day before yesterday. Okay, what matters is whether it rained today or not to predict whether it's going to rain tomorrow or not. Okay, so a random process, this is a random process with memoryless transitions, moves from one state to another. Okay, just for example, suppose you have three states. Okay, a day can be a rainy day, or it can be a cloudy day, or it can be a sunny day. Okay, so this moves from one state to another state. Say for example, today if it is rainy, okay, state A1. It can be A1 tomorrow again, okay, it can be a rainy day tomorrow also, or it can be a cloudy day, or it can be a sunny day. Okay, similarly, suppose it's a cloudy day today, suppose it is A2, the state is A2, tomorrow it can be A1 rain, A2 cloudy, and A3 sunny. Okay, or the third case, suppose it is sunny today, tomorrow it can be rainy, tomorrow it can be cloudy, tomorrow it can be sunny. So these transitions will happen with some probabilities. Okay, this is represented by a matrix called as transition matrix. Okay, so take this example. So this is the matrix, transition matrix. So what this says is, suppose it is sunny day today, the probability that tomorrow also it's going to be sunny day is 0.6. Suppose today it is sunny day, same row, first row. Suppose it is sunny day, so first row is for sunny. Okay, today suppose it is sunny day, the tomorrow the probability that tomorrow it's going to be a cloudy day is 0.3. And today suppose it is sunny day, tomorrow the probability that tomorrow it's going to be a rainy day is 0.1. Okay, this is for from first state to any other state. All right, similarly second row is for second state. Suppose today is cloudy, the probability that tomorrow it's going to be sunny is 0.4. Tomorrow also it is going to be cloudy. Today it's cloudy and tomorrow also it's going to be cloudy is 0.4. Today it's cloudy but tomorrow it's going to be rainy is 0.2. Okay, so hope you have understood how to write the transition matrix. I'll just take this case also. Suppose today if it is rainy, that means I am taking the third row for rainy case. Okay, tomorrow it's going to be sunny is 0.2. Tomorrow it's going to be cloudy is 0.5. Today rainy and tomorrow also it's going to be rainy is 0.3. One thing you need to remember is every row will be a probability vector. That means sum of the values in every row, sum of the probabilities in every row is going to be 1. Okay, therefore it is a stochastic matrix. All right, so 0.2 plus 0.5 plus 0.3 is 1. All right, I'll give a couple of examples to understand how to write a transition matrix with given situation. All right, let's take this first example. Dhriti follows a predictable study pattern. Okay, so one, she watches YouTube lectures on some days, and she solves the practice problems on some days, and she'll relax for some days. Okay, so three states are there. A1, YouTube lecture she watches. A2, she solves the practice problems. And A3, she relaxes. Alright. So three states are there. Let us take the data from this note and try to write the transition matrix. So three states I'll write. Today she might have watched YouTube lectures, she might have solved the practice problems, or she might have relaxed. Okay. And what's going to happen tomorrow? What is the probability that she will watch the YouTube lectures again? What is the probability that she will solve the practice problems? And what is the probability that she is going to relax? Since three states are there, this is going to be a 3 cross 3 matrix. Okay, this matrix is going to be a 3 cross 3 matrix. Alright, so now I'll read this. Suppose she watches YouTube lectures. There is a 50% chance she will watch the lectures again tomorrow. That means today if she has watched YouTube lectures, the probability is 0.5, 50% chance. Probability that 0.5 that tomorrow also she is going to watch YouTube lectures. Okay. And 30% chance she will switch to solve practice problem. So today if she has watched YouTube lectures, tomorrow she will solve the practice problems with a probability of 0.3, 30% chance. And remaining 20% will be for relaxing. Okay. Today if she has watched YouTube lectures, the probability that tomorrow she will relax is 0.2. Okay. So that is the probability of switching from one state to first state to any other state. Okay. Now let me take the second state. Suppose she has solved the practice problems today. Okay. What are the different probabilities of different states? Suppose today she has solved the practice problems. Okay. If she has solved the practice problems today, tomorrow she will return to watch the lectures is 20%. Okay. Today suppose she has solved the practice problem, the probability that tomorrow she will return to YouTube lectures is 0.2, 20% chance, 0.2. Or continues practicing. Today she has practiced, tomorrow also she continues to practice with the probability 60% chance. 60% is 0.6 is the probability. Okay. And today if she has solved the practice problem, the probability that she relaxes tomorrow is 0.2. Okay. So this completes the second row. Okay. And now I'll take the third state, relax. Suppose she has relaxed today. What she with what probability she is going to have these three different states. Okay. So suppose Dhriti is relaxing today. 0.3 is the probability that she will start watching the lectures next day. Today she has relaxed, 30% chance, 0.3 is the probability that she will watch the YouTube lectures. Alright. And 0.4 is the probability she will solve the practice problems. So 0.4 and 0.3 is the probability she will continue relaxing. Today she has relaxed, tomorrow also she might relax again. That with the probability 0.3. Alright. So this is the transition matrix. Very easy, very easily you can understand the problems and try to write the transition matrix. Suppose there are 5 states, it is going to be 5 cross 5 matrix. Okay. So you can observe this is a stochastic matrix because every row is a probability vector. In every row the sum is going to be 1. Alright. Let me consider one more example. Okay. So let me read this first. 3 boys A, B and C. They are throwing the ball to each other. So A, B and C, they are throwing the ball. All right. And okay, let me consider, I mean, read all the sentences, then let me write what's happening here. Three boys A, B, C are throwing the ball to each other. A always throws the ball to B. Okay. A throws the ball to B always. And B always throws the ball to C. C is as likely to throw the ball to B as to A. Okay. So A is always targeting B. B is always targeting C. But C is not targeting anyone. So C is throwing A and B with same probability. Alright. So 3C is throwing to both of them. He is throwing to A as well as he is throwing to B. So here I have three states. One is A, other is B, and third is C. Okay, A, B, and C. So suppose now at present A has the ball with him. What is the probability that A will have the ball after one step? Okay, so definitely he will not have, because he will throw to someone else. Okay, so the probability from A to A is going to be 0. And clearly it's given that A always throws the ball to B. Okay, so it's full probability, 100% chance that A always throws it to B. So the probability from A to B is going to be 1. And definitely he will not throw to C, because it is already said that he always throws to B. Okay, so that completes the first row. Now let us assume B has the ball. Now what is the probability that B will throw to A? It is 0, because it's given that B always throws the ball to C only. He will never throw it to A. So B to A is 0. And B to B, definitely it is 0, because he cannot throw it to himself. And B always throw to C means it's going to be 1. Okay. Now the last case. C is just as likely to throw the ball to B as to A. That means with equal probabilities. One observation is that the sum is going to be 1. Okay. Because it's going to be a stochastic matrix. C will never throw to C. So it will be 0. So he will throw to A and or to B with equal probabilities. So this sum should be equal to 1. So what is going to be the equal probability with sum 1? So two cases. So one is, this is 1 plus 1. This sum should be equal to 1. That means this is going to be 1 by 2 and this is also going to be 1 by 2. Alright. So finally you can complete the probabilities by writing 1 by 2 here and 1 by 2 here. Okay. Now you can observe that C throws to both A and B with equal probabilities. Equal probabilities, that means 50% chance to both of them. Okay. 1 by 2 and 1 by 2. So sum is going to be 1 in every row. Alright. So I hope you have understood how to write the transition matrix. You can take more examples and you can try to write yourself. And in the next class we will understand what is the use of this, okay, in calculation of higher transition probability. That means suppose you know this transition matrix, what's going to happen after 10 steps. Suppose I want to find what's the probability that C will have the ball after 15 steps. Okay, what is the probability that B will have the ball after 8 steps? Okay, after 8 throws, what is the probability that B will have the ball with him? Okay, these are called higher transition probabilities. Okay, that I'll explain in the next class. And Markov chains are used in many fields. I have listed few of them. All right, Google PageRank algorithms, Google PageRank algorithm, stock price movement, weather prediction, speech recognition, queuing system, board games like snakes and ladders, etc. Okay. So yeah, thank you. In the next class, we'll discuss what are higher transition probabilities and how to calculate them.